So in the previous video, we saw how we could adhere to the DRY principle, do not repeat yourself principle, and we got rid of these repetitions, one attribute and one method, which was repeated in all the animals. We just made a common animal class and we pushed all the commonalities upwards and removed them in the individual child classes. And that's how we were able to get it going. And we had no change in the output displayed in the main program. We also saw that we cannot do the same thing for climb because what they're doing is same, but how they're doing is different. So let's see how we can deal with this situation. Now we can let this function be as it is, since it is technically not a repetition of logic here, but it's still we can take advantage of polymorphism here. See, basically, all these guys, these animals are similar, and all the behaviors of them are similar. So whenever we have such similar but not same behaviors, we can make use of polymorphism and take advantage of it in writing flexible, extensible, and maintainable code. All of which may not be evident right now, but watch what I do in this video, and I'll also be explaining why I do in more detail in the next video. So what I wanted to do here is, since the climb is similar but not the same, I'll go ahead and create a public and abstract method called climb, and this is just a signature. Let's see what the error is. Correct. So basically compiler is telling about a rule. So the moment you have an abstract function, I'll tell you why I went this with subtract function. You will also have to define the containing class as abstract. So the error is off. So basically now I'm only declaring this function and not implementing. So this is a kind of contract that all the other children of this animal should follow. So basically the contract says that you need to have a climb method which returns nothing and takes nothing. It could be anything else. I mean, you could take parameters, return something. But for the time being, let's consider this in a simplest form. So once we have this contract, you can see that there are errors shown in the respective child classes saying that, let's see what the error is. Does not implement the abstract member animal.climb, but you can say there is already a climb. So it looks like you're actually trying to redefine it. So in order to tell the compiler that no, I would want to define it here. So you will just fix it or suffix it with the word virtual. There is still an error here. Yeah. So my bad. So basically, we need to override it. I'll tell you when we'll have to use the virtual keyword a little later or probably in some other video. But basically, it's simple. We are trying to override what's been defined here, okay, in the child class. So we'll have to tell the compiler that, hey, look, I know I had a contract, or basically this child had a contract of implementing the climb, and here I am implementing the climb. But maybe there could have been a better word than override in this situation, but nevertheless we'll stick with what has been provided here, and then the compiler is happy. So similarly, I just have to do this same thing in other places here. In fact, if I just do a space and say override, I'm getting it, and you see the errors are also being removed. We do have this here, and again, no effect whatsoever on the main program. There are no errors, but more importantly, we'll have to just ensure that we are still getting the same behavior like what we saw initially. There you go. Tom is created, he's eating, he's climbing the roof, this guy is climbing on the steps, this guy is actually climbing on the tree. So here we have, so did you also notice that we didn't have to change any of these things? It is, kind of a contract that every animal follows, that, hey, it implements climb. How you do it is a different matter. So you see, this is also polymorphism in action. So basically, these are all similar things, but so these are similar behaviors on similar objects. So how you call it is also similar. So this level of polymorphism makes the code much more easier to understand, to extend, and to keep it uniform, so that we can actually build much more better code. Now, remember we talked about having a lot of repetitions here, and what if we had hundreds or even hundreds of thousands of objects pull up from database? So would we actually end up creating variables like this and invoking all the functions? No, we won't do it, but we haven't solved that problem either, but we are getting close to it. So we'll probably look at it in some time. But nevertheless, we've solved this one problem and made this program a lot more polymorphic, thereby setting the stage for some more beautiful things which will happen as and when we see other stuff. And also notice this parrot is still having an method called fly here, something which is very specific to a parent only. There is no way we'll put it in animal. It doesn't make sense, since animals cannot fly, and hence this specific behavior you will not find anywhere except for the parrot class itself. So in order to put it this way, all the generic behaviors and attributes will go on the top in the hierarchy, which is the animal, and all the specific attributes and the behaviors will remain in the children. Here we do not have any specific attribute, but we can imagine one, maybe something like int wing length. So if you see, this is something which is not derived from animals, because all animals don't have wings. A parrot has something more specific. So we can go ahead and have them as usual, and we can, capture those logic which are specific at a specific level itself. But in order to keep this video series more focused on whatever we wanted to do with respect to inheritance, abstract classes, and interfaces, let's not continue with this particular situation. So I'll just take them off. So we'll stick to what we wanted to initially discuss, which are only these things. And coming to the effect of the animal class being marked as abstract. So now this will have some ramifications, in fact something very much wanted actually, which I'll also discuss in the upcoming video. But before that, I do want to mention about this fly method here. So what if we got into a situation, or what if we wanted to make our application more extendable? So what if we had, or we will get many more birds to implement in the future? Something like a peacock or a kingfisher, and there could be dozens of them. And if by now you must have guessed, this fly method also will be repeated all across these classes, because that's a common behavior of all birds. So we can provision this better by actually introducing one more level of abstraction and putting this fly method there, thereby keeping our code in a very extensible state, and also provide some other benefits which I'll be discussing further in the next video.